in on recursion and iteration. We're not actually going to get to the iteration today. We're just going to focus in on the recursion. We're going to consider the following: 5, 7, 9, 11, etc. This is something we've seen before. We've seen this exact one before. Showed up in a warm-up earlier in the chapter. What is this thing? Arithmetic what? Sequence. What do we know about this arithmetic sequence? Increases by 2, which is our constant difference for arithmetic. Okay, what else do we know? What's the other important thing we tend to talk about? How it increases and a sub 1 value, where it starts. A sub 1 is 5. These important pieces of information allow us to do things like, wow, I can spell, don't mind me. Write an equation for the nth term of the sequence. And when I ask you to write an equation for the nth term of a sequence, we determine that arithmetic geometric to tell us what formula to use. And since it is arithmetic, we use this formula. And I plug numbers in. Where do I plug numbers into this equation to write the arithmetic sequence equation? What changes into numbers? I didn't hear you right. A sub 1. I heard X and Y and was very confused. A sub 1 becomes a number. What else becomes a number? D. Everything else stayed letters. But with arithmetic, we should not leave it this way, because generally speaking, if you can simplify things, you should. Distribute and combine like terms. For the sake of time, I'm just going to do that for you. It should turn into a sub n is equal to 2n plus 3. So, this is what we've been doing since 10.2. This phrasing, this type of equation, is what's known as an explicit formula. An explicit formula is one in which I can say, what's the 500th term of the sequence? And you should be able to figure that out by just plugging in the number 500. Today, we're getting into what are known as recursive formulas. A recursive formula is one that looks a little bit different. A recursive formula is a formula that tells the pattern based on previous terms. I don't know how much you recall about when we started this chapter, but when we very first started this chapter, I gave you a bunch of sequences and said, find the pattern. Tell me what you know about them. And we went through and we found out, and that's where we defined our arithmetic versus our geometric sequences. And one of the things we talked about is that what makes a sequence unique is not only how it changes, but where it starts. Essentially, focusing in on a pattern of how it changes and where it starts, you're focusing in on its recursive idea. Recursive formulas, recursive ideas are kind of a little more intuitive than explicit. Because if I showed you a sub n is equal to 2n plus 3, you wouldn't necessarily be able to look at it and be like, okay, this is the pattern. Could you figure it out? Sure, because you can plug in 1 and 2 and 3 and 4 and 5, and then you'd have your first 5 terms and you could see what's going on. Recursive formulas tend to be a little more straightforward. Now let's say I was given that same equation, and I instead asked you to write the recursive formula for 5, 7, 9, 11, etc. It would look like this. A sub n is equal to a sub n minus 1 plus 2, and then it would also tell you a sub 1 is equal to 5. This is what a recursive formula looks like. Another form of what this equation could look like is it could have looked like a sub n plus 1 is equal to a sub n plus 2, where a sub 1 is equal to 5. These are two different forms of the exact same equation. Note the n minus 1 and the n plus 1, those are all in the subscripts. Those are all those tiny little letters with that a sub n. When it comes to a recursive formula, the key thing that you want to look at is the comparison of these subscripts, because when it comes to our recursive formulas, you're going to see things like a sub n minus 1, a sub n minus 2, a sub n plus 1, a sub n plus 2. Look at the comparison of these subscripts. N plus 1 as compared to just n. How would you describe those as number-wise? How do you compare n plus 1 to n? And if that's not clear, let's think of them as numbers. If n plus 1 was 5, what would be n? 4. If n plus 1 was 8, what would be n? 7. If n plus 1 was 20, what would be n? How do these numbers compare? How does 5 compare to 4? How does 8 compare to 7? How does 20 compare to 19? The first number is always 1 more. So, to go from here to here, the number in the subscript gets 1 smaller to go from here to here. It did the same thing on the first one. Now those subscripts tell you the location of numbers in the sequence. which means what this is telling me, as the subscript gets one smaller, the location gets one smaller. And if you bring the location one smaller, you're technically bringing it one earlier. In other words, if you try to compare a sub n to a sub n minus 1, this is a term, and this is the previous term, because it's one location earlier in the list. If I started, say, with a sub n plus 1 compared to a sub n, this is still a term in the list, and this would be its previous term, because the subscript is one smaller. Okay, what are we going to do with this information? Today, our instructions, we're just going to have one set of instructions that we're working with today. And the set of instructions that we're working with today are going to be find the first 5 terms of the sequence. Now, one of the weird things that our book does in this section is it, for some reason, decides it doesn't always have to be a sub n. It could be any letter sub n. Why do they do that? I have no earthly idea. But don't be shocked when you see things like this. B sub n is equal to b sub n minus 1 plus 4. And then a recursive formula will also always need to tell you where to start. So it's always going to give you a sub 1. Sometimes a sub 1 and a sub 2, depending upon the situation. Since this one's b sub things, it's giving you b sub 1. So, generally speaking, when we're working with a formula, this is the term we're looking for. And according to this formula, that term is equal to whatever this term is. Look at the subscript. How much smaller is the subscript of the term we're looking for and this one? Minus 1, so 1 smaller. If you go 1 further back in the list, that is the previous term. And it says to add 4 to it. Oftentimes with these ones, I write them out in words because it makes more sense in words to people. So if I want to find a term in this list, I'm going to take the previous term and I'm going to add 4. But according to this, I'm going to start with the number 3. So first 5 terms, first one's 3. To get to the next term, previous term plus 4. Previous term was 3, add 4, and we get 7. And then move on to find the next term. According to this, to find a term, we take the previous term and add 4. If this is the term I'm looking for, the previous term, the term right before it is 7. I take 7 and I add 4. What is 7 plus 4? 11. How would we find the next term? Previous term plus 4. What's the previous term this time? 11. What's 11 plus 4? 15. How do I find the next term? Add 4 again. 15 plus 4. 19. First 5 terms. That's what all of our instructions are going to be today, is find the first 5 terms. When I go to write this out in words, the one that's alone is always the one that I just reference as the term. Because generally it's the term you're looking for. Term is equal to. Formula says -2. That's a plain number, -2. What's in between the -2 and the r sub n? What hides in between them? Multiplication. Times. R sub n compared to r sub n plus 1. What happened to the subscript? How much smaller is it from the term to this one? 1 smaller. If it's 1 smaller, it's 1 earlier, aka it's the previous term. -2 times the previous term plus 1. Miriam, where should I start this list of the first 5 terms? 5. I gave you r sub 1. We start there. First number in the list is 5. Danielle, how do I find the next number in the list? Multiply by -2 and then add 1. -2 times 5 plus 1. Aubrey, what do we get?
-9.
Beautiful. Austin, how would I get the next number? Yes. Wendu, what do we get when we do that? I didn't realize you didn't have a voice. I'm sorry. Okay, Jack, how do I find the next number? -2 gets multiplied by 19 plus 1. -2 times 19 is -38 plus 1 is -37. Be careful with your positives and negatives. And then I do it one more time. -2 gets multiplied by -37 plus 1. -2 times -37 is a positive 74, plus 1 is 75. How do I know I'm done? It wanted 5 terms. Okay. Curveball at you. A sub n is equal to 3n plus 2. What do you notice? There's no previous term in the formula, which means this is not recursive. It's explicit. How do you find the first 5 terms in an explicit formula? Plug in 1, 2, 3, 4, and 5. It's also why it didn't tell you the first term. So, plug in 1, 3 times 1 is 3, plus 2 is 5. To find the second term, I'm plugging in 2, not the previous term. It's not what it says. It says plug in 2. 2 times 3 is 6, plus 2 is 8. Plug in 3. 3 times 3 is 9, plus 2 is 11. At some point, you probably are going to figure out the formula and notice that this is adding 3 every time. We're back to a recursive formula, but this one's got something a little different about it too. It has both a previous term and just a plain n. So, term is equal to. We've often been dealing with the previous terms. Question, is that the previous term? Is that the term right before it? Yeah. Plus 2 getting multiplied by n. Now you gotta be careful with this, because now we've got multiple subscripts. When there's multiple subscripts going on, it's not just a sub n. There's an a sub n, there's an a sub n minus 1, maybe there's an a sub n plus 1, maybe there's an a sub n minus 2. I don't know. This one just has a sub n and a sub n minus 1. This is a position. That's what n represents. It's a position. But you have to pay attention to which term it's matching the position of. Is this position of the term we're looking for or of the previous term? Why are you thinking it's this one? Because that's where this is matching. It is matching the n. We start the same way with a sub 1. To get to the next term, we gotta be careful. To go from here to here, it says to take the previous term, happens to be 1, plus 2 times 2. Why 2? We're looking for the second term. We're looking for a sub 2. A sub 2's position is in the second spot. 1 plus 2 times 2. Order of operations, make sure you do the multiply before the add. 2 times 2 is 4, plus 1 is 5. Previous term plus 2 times position of the term we're looking for. We're looking for the term in what spot? The third spot. So be careful with this. 2 times 3 is 6, plus 5 is 11. previous term is 11 plus 2 times. This time I'm looking for the number in the fourth spot. We get 19. Last but not least, previous term plus 2 times. We're looking for the fifth spot. 29. So sometimes these are going to be a little bit odd. One more quick example I want to show you. Sorry. Sometimes they might do this. The term is equal to what's the change in my subscript here? How much smaller is this one? It's 2 smaller, which means I need the term that's not previous, but back 2 spots. It's the difference between n plus 1 and n minus 1. Now you can straight up do subtraction if you want. This is the very, very formal way to do it. N plus 1 minus n plus 1. How much? Why did I write a 2? Cancel, cancel, 2 prior. That's a very formal way to do it. Or the more traditional way is, what's 1 smaller than this? N. What's 1 smaller than that? Essentially, I just looked, and if I subtract 1, I get to n. If I subtract 1 again, I get to here. I subtracted 1 twice. How do you change a plus 1 to a minus 1? You subtract it. I'm going to use the word prior for this one instead. But sometimes they might do this. A term is equal to the one that's 2 prior plus 2 times the previous term. Tells you where to start. Tells you to start at 3. Tells you to move on to 1 next. On ones where they go back 2 spots, they have to tell you 2 starting points. To get from here to here, which number is 2 prior to this one? 3 plus 2 times, what's the previous term? 1. 2 times 1 is 2 plus 3 is 5. To get this term, 2 prior is 1 plus 2 times the previous term is 5. 2 times 5 is 10 plus 1 is 11. What term is 2 spots earlier? 5 plus 2 times the previous was 11. 27. Sometimes they might do that. Okay. We are on page 695, day 1. It is problems 12 through 23. They all should be looking for the 5 first terms. First 5 terms. I said that weird.